Good evening everyone. Myself Gautam Sarma. I welcome you all in a Sapience Education. Today I am going to discuss about the AC generator. Perhaps this is the part 7 video of the alternating current. So here we will go discuss each and everything about the AC generator, right? So before that we need to understand that what is wattless current. The current which does not consume power for its maintenance in a circuit is called wattless current. Now let us consider if there is a resistive circuit. Let us consider this is a resistive circuit, and if you apply a AC supply, so what will happen? We will get a heat and heat will be lost. So if heat will be lost, it means there is a power loss, right? When we talk about inductor or capacitive circuit, when we are talking about inductive or capacitive circuit, that is L or it may be capacitive circuit. So what happens for this scenario? We should understand, as we know that if you want to find the average power loss, so what we will get? P average is equal to ERMS into IRMS into cos phi, where phi is the phase difference. Now we know that this is a phase difference. Now if we talk about the phase, so for this resistive circuit phi is equal to 0, but when we talk about inductive circuit, so phi is equal to pi by 2, and for either it is lagging or ahead, or if, for a capacitive circuit, if this is a capacitor, so for this also phi will be equal to pi by 2. It has minus pi by 2 and plus pi by 2. Now if we talk about the average power for loss for inductive circuit, so this will be 0, and for average power loss for the capacitive circuit, so P average for the capacitive circuit will be also 0. What do you mean by this? It means that there is a no loss of the power. So it means that whenever current, we know that current is flowing but there is a no loss of power. That's why this type of current is known as wattless current. So I hope you have understood this term, wattless current. Now let us discuss about the AC generator. So what is AC generator? As we have already studied about lots about the AC, that is AC alternating current, is or alternating current or alternating voltage. So we know that they are just creating a either current or a voltage in this form, that is sinusoidal valve. One time it will create positive and one time it will create a negative, right? So positive negative it will happen. Got it? Now, so how this is being generated, so we will discuss about this. So before that we need to understand that how it is being made. So let us suppose this is your magnet. So strong magnet is being used here. Strong magnet is used here, so it is north pole as well as it is your south pole, and in this between a coil is placed and this coil is placed, right? And this coil is placed means what? Coil is made up of a armature, that is soft iron. So let us consider this is a coil and it has been made in a proper way. With the armature there is a soft iron, and around soft iron there is a iron, there is a this wire is wounded, right? Wire is wounded, right? Wire is wounded around this, okay? And this is the circuit. Now what do you mean by principle? So when we talk about the principle, so what is the basic principle? Before that you need to understand that it is first of all it is consist of armature, which is being wounded by the wire. And see, one of the wire is connected with the one slip ring and another wire is connected with the another slip ring, and these both are not connected directly. So both the wire is not connected directly here, and there is a carbon brush here so that it won't get attached completely, so that there may be possibility of um, breakdown. So that's why a carbon brush is being touched, so it means that when it will move or when induced current will be formed, so the current will go through this, right? So this is known as slip ring, and this is the axis, and there Here there is a turbine is being connected. Turbine is being connected. Turbine means what? Rotating. So there is a device or any mechanism where we can produce a rotation or where we can create a rotation. So these are the basic structure. Now we will talk about principle. So first of all, what is the basic principle for the AC generator? So if you talk about the basic generator, if we talk about basic principle, so the basic principle by which it is being run is known as induction electromagnetic induction. Okay, so the parts, field magnet or strong field magnet. First part is your strong magnet. Second part is armature. What we have taught just now, we have talked, this is the part, this part is known as armature, this part is known as armature. Now third one is slip rings. Slip ring, it will help not to be disconnected. Current not to be disconnected. Fourth one is brushes. So brush will not completely attach, so it is just touching the slip ring. Okay, now we know that when it will rotate, so there is a change in a flux. When it will rotate means there is a change in a flux, and when there is a change in flux, there is a induced EMF. So let us consider let us consider now the EMF is equal to, that is EMF. Let us consider EMF. If we talk about the EMF, or sorry, flux, so flux will be equal to B dot A. But for if armature is being wounded by n number of turns, so this will be NBA. So finally it can also be written as NBA cos theta, where theta is a change in an angle, right? Now we know that theta is the angle. Theta can be written as omega t, or theta per unit time is omega t. So from here theta can be written as omega t, right? So we can, in place of theta, we can write, in place of theta we can write phi is equal to NBA cos omega t. So this is phi is equal to NBA cos omega t. Got it? Now as we know that if there is a change in the flux happens, there is change in flux happens. Why there is a change in flux happens? Because when it will rotate, see, when you observe this, so when it will rotate, so what will happen, there will be a change in a flux, and the change in flux will happen, right? There is a change in a flux which will happen, right? And this change in a flux will result in the induced EMF. Induced EMF result in induced EMF. Right? So finally EMF can be written as minus d phi by dt. So in place of why? Because it will be negative, because it will be in an opposite nature. So there will be minus d by dt of a cos omega t. Now when you do this, so this will be minus NBA in this is known as sine omega t. So this is known as E, right? Now for maximum, so, so there will be a minus, so minus minus will get cancelled. Now E will be equal to E naught when sine omega t will we have a value of 1, because this is the maximum condition. So in maximum condition E is equal to E naught when sine is equal to omega t, it means you will got NBA. So from here we have got uh, E naught as NBA, right? NBA, one more important thing, when I omega, right, it is NBA omega, right? So we have got E naught as a NBA omega, we have got E as a E naught as a NBA omega. So finally we have got the equation as EMF equation as E is equal to E naught sine omega t. So it means that whatever EMF we are getting, so it is in sinusoidal form. So this is a sinusoidal form, right? This is a sinusoidal form, right? Got it? I hope you have understood this. Now let us talk about the transformer. So this is all about AC generator, okay, and AC generator, and this has been used in generating the power. So what happens when we observe the power plant? So let us consider there is a power plant. In power plant, what happens? There is a mechanism in which AC generator has been put in such a way that it will, they will give a rotation by the help of they will give a mechanical movement, mechanical rotation by either water or steam. So this rotation will be created or generated in the form of electricity. So in this way AC generator is being working. I hope you have understood. Thank you for watching my video.